provided the crude force, referred to as a negative lift, in order to push the front tyres much harder into the racetrack than simply the weight of the car alone. To demonstrate how the air flows around and over the bodywork, I'm going to use this as air. Now I need some assistance. Probably the most important element is the front wing. Let's take a closer look. It's made up of a main plane which hangs from the nose. It's supported by a secondary flap. This slot gap and the angle of the flap determines the level of downforce. On the end of the flap there's a further gurney flap, a return angle, which helps generate the downforce. That's a low pressure area just here behind the wing. As the air travels over, we get upwash and also a lot of very turbulent air coming off the side, and vortices tend to go inboard and disturb the air underneath the car. Wing end fences have a big role to play in controlling that very turbulent air. Now the real challenge begins. The next section of the car comprises many elements which must work in unison to both control the wake and flow correct the upwash. Surprisingly, the top suspension makes a handshake of the air as it moves to the midsection. When it's all working well, the drivers have total blind faith and confidence that the car will stick despite as brake ducts turn through the airstream, creating further disturbance. Above the driver's head is the engineer intake, and it's important to present this area with high velocity out to ensure that all 10 cylinders are fed good quality air. Air travelling through the system using chimneys to extract the hot and energised air. Along the side pods are many winglets which create more downforce and manage the air back inboard. The rear of the underbody. The upturn in order to enhance this suction and evacuate the air travelling under the car in a controlled and high energy way. The rear wing package must help extract that air using the lower element and create downforce of its own from the flow passing over the car from the upper element. It's like an upside-down aeroplane wing forcing the car down. The side wings of today's Formula One cars, it's no wonder most of the teams are spending tens of millions of pounds creating new wind tunnels.